that I explained the process to create a magnet. You remember? You have a piece of iron. You wrap it a coil. When you apply power in the coil, what happened with the iron?
Becomes magnet.
Become magnet. If you check in the moment that you apply power in the coil, if this is the piece of iron, when you apply the power, when you close the circuit, you see that the iron move a little. Why?
Yeah.
Because the current is moving in the direction of this finger. You see? If the coil is wrapped in this direction and the current is flowing in this direction, at the end of the day, by induction, the piece of metal moves in the same direction of the current. You understand? This is the eddy Hertz current. Yeah? This is the current, the direction of the flow, push the metal in this direction. Okay, if I connect a battery here, negative and positive, and I connect the positive in one side, doesn't matter in what position you connect the positive and the negative, no problem. Immediately, you have a switch here. Immediately you close the switch, what happened with the piece of iron? Go down, because the current push down and close the gap between this, and the current here, 50 amps, pass through the other side and continue 50 amps. This is the relay. This is a spring, the blue one. It's a plastic spring to return the metal when you remove the current. Yeah, and you hear, no?
Yeah.
That's the relay. Can you imagine the millions of possibilities with those relays? You can start remote motors, equipment. For example, you have in your bed the switch, and you can activate a relay to open the door, to open the windows. Yeah, millions of applications. This is the beginning of robotics. But the most interesting part is this. This is a relay. I am going to create another one. But here the piece of iron is longer and goes out. And I have the same, the connection of the battery, the negative and the positive. No? What happened when I connect the power of the battery? What happened with the iron?
Push.
Oh, this is exactly that like this, but with external mechanical movement. Oh, wow. This is the first step to create robots, because you convert electrical signals into mechanical movements. Wow. This is to start and stop a diesel engine. When you bring power here, when you select stop, the button off, what happened with this solenoid? And no more fuel enter in the fuel pump and stop the engine. Yeah? There are in your boat, in your car, there are millions of applications of solenoids. Give me example in your car of your boat of solenoids. You remember the door, the window, when you put fuel,
Yeah.
you have a button and the door. This is one solenoid. Other one,
Yeah, the window switches.
at the windows.
Yeah, the window switches.
You hear, no? And the lock. So other one. Give me more. There are a lot. Solenoid.
Sunroof.
Excuse me?
Sunroof.
Yes. Yeah, the sunroof is an activation with the solenoid. Oh, in the transmission,
Yeah.
you have 1 million of solenoid to activate the forward pump, the reverse pump. In the body of valves, we are going to study here the automatic transmission. There are a lot of solenoids. No, there are millions of solenoids. This is magic. The solenoid with mechanical external movement and the relay. Both of them close the contact. The current pass from this point through this, but this one additionally have external movement. This is exactly the same. The current pass from this point through this, but no external movement because the piece of metal is short. Right? Relays and solenoid, and we are going to use a lot of them. I think that now we are ready to create one of the most important circuits that we do every day in marine application. Is this? What is this? This is the bilge pump. No? This is the motor, the pump. When the pump is running, suction the water here and send the water over there. That's the pump. It's a motor with an internal pump, centrifugal pump. And this is what? This is flow switch. Once again, switch. What is the function of the switch?
Fast current.
Interrupt or allow the flow of current. Switch. Exactly like this. This is exactly like this. This one is activated with your hand, and this one with the level of water. The level of water, you hear? This one? Exactly the same. Pay attention, my friend. If I have the pump with positive and negative, in which side I connect the positive, in which one I connect the negative?
Both positive.
Positive, only positive. If you put positive here and negative here, and this one, kaboom. All right? This is an interrupter of the same cable. The positive coming from the switch, enter here, pass over there, and activate the pump. Ready? This is a switch. Switch, float switch. Give me an example of flow switch in your home, in your car, in your boat.
Gas tank.
The gas tank. Other one. The water tank.
The water tank.
There are a lot of switches.
Gas and float.
In gas, it's a flow switch, but it's not a switch, it's a sensor to indicate the level, no? It's a switch because when the flow reach the maximum, activate one LED, and the LED indicate that it's full, the tank. This is another. It's a sensor, but it's also flow switch. Both of them.